All right, hello. Okay, in this video, we're going to be going through and talking about how to actually draw free body diagrams, how to go about it in a relatively logical and ordered pattern to make sure that you're getting everything. So I have listed the 9 potential forces that you need to be able to identify in any given problem. Now, we are starting on the last page of the packet because there's only 3 on here. There's some stuff and information up here on the top that is an artifact because this is a picture and I couldn't get it edited without having to lose all these pictures. So there are a couple of things I'm going to have you cross out. So first off, the 3 boxes at the bottom, cross out. You're not doing any of this. And this one turned out to be a little more complicated than I was intending, so we're not going to do this one. We are going to do these 2, and then I'm going to do a couple off of the first page of the worksheet as well. So this is page 4, the last page of your worksheet. And there is a blank version of this available if you don't like my sketchy drawings. Yeah, I recommend going through in this order to try to identify stuff. Start with weight. Does the thing have gravity? Okay, does it have weight? Is it experiencing a gravitational force? Well, 9 times out of 10, yes, it is. Okay, what direction is that? That's always going to be straight down. Okay, so for example, in our first one here, we have a runner going uphill into a headwind. Okay, so we have a guy running up a hill. There's a headwind. He's going this way. The wind is blowing this way. Hill. Okay, gravity is the first thing we're looking at. Definitely going to be gravity. So there is going to be a downward arrow, FG. Okay. Next, we have our 3 flight forces, thrust, drag, and lift. Well, does this guy have a jet engine attached to him? No. So there is no thrust. Drag. Is he moving through a fluid? Yes. But is that drag force measurable? Is it having a significant effect? Well, wind is basically just amplified drag. Okay, when someone is running into or with the wind, drag becomes measurable. It's a significant effect. So he is going to be experiencing drag. So the drag is going to be pushing against him because he's running into the wind. So that's going to be this way, parallel to the ground, pushing him backwards. Okay, and then we have lift. Again, he's not flying. There's no airfoil here, so there's no lift. That leaves us with our last 5. We have normal force. Is he in contact with the ground? Yes, he is. So there has to be a normal force. Normal force is always perpendicular to the surface of contact. So if the ground is the surface of contact, then the normal force should be off this way. Not straight up, but angled slightly. Okay. Then we have friction. Is he in contact with the ground? Yes. So there has to be a frictional force here. This one, the friction's a little tricky. Okay, if he was standing still on this hill, friction would definitely be up the hill. Okay, but he's running, so it's more dependent on what direction is he actually going. So he's running this way, and his foot then is pushing this way against the ground. His foot is trying to go this way. That means that the friction is in fact still up the hill. So it's going to be parallel to the surface, but in this direction. So opposite our drag force. Buoyancy. Yeah, there's a buoyancy force, but he's in air, and that buoyancy force is not really going to have a measurable effect. So we can ignore the buoyancy force. That leaves us with tension and applied force. Tension only matters if there's a rope. Now, if you've ever done the training technique where you run and somebody behind you has a bungee cord that's attaching your back to their bike, then there would be a tension. Okay, excellent training technique, by the way, if you want to really force yourself to deal with unexpected. But that is not the case here, so there is no tension. Okay, applied force, he is not experiencing an applied force. No one is pushing him or pulling on him, so there's no applied force here. So these would be the four forces that we have to have. So this is going to be it for this one. Okay, next one here, we have a fighter jet starting an attack dive. So I'm probably the worst at drawing planes, so just take it. Just kind of deal. We'll get over that. Okay, so same deal. We're going to start with gravity. Is this plane relatively near the surface of the Earth? It's definitely in the atmosphere. It has weight. It's definitely going to have gravity, and that gravity is always straight down. Okay, so we have weight pulling down. Okay, does this have thrust? Yes, it does. And here's where we have to pay attention. What direction is the thrust causing the jet to go in? The thrust is coming out the back, but it's pushing the jet forward. So the thrust is actually exerting a forward force on the jet. Okay? It's pushing the jet forward. Yes, the exhaust is coming out the back, but this is asking, when we're drawing a free body diagram, what direction is that thrust pushing the jet, the plane here? And it's pushing that jet forward. Okay? Then we have drag and lift. This is a plane, so yes, it's going to have both drag and lift. The drag is going to be opposing its motion because it's friction. It's basically just air friction, so we'll have drag going backwards. Lift is always going to be pulling up on the plane. Okay, so if we take this to be the top of the plane, unless it's flying upside down, which admittedly you can't really tell here, but I feel that was implied. Lift is always going to be perpendicular to the wing, and it's going to be pulling the wing up. So lift has to be this way. Then we have our 5 contact. Is there a normal force? The plane is not in contact with any solid surface, so there is no normal force. Friction, again, not in contact with any solid surface, so no friction. Buoyancy, arguably yes, but again, it's in the atmosphere. This is a very heavy object. The buoyancy force here is going to be negligible. It's not having a measurable effect, so we can ignore buoyancy. Then we have tension and applied. Again, there's no string here, so we're not going to have any tension. Applied, unless there's a guy hanging onto the wing who would be pulling on the wing, there's no applied force here. So it's just going to be these 4 this time. A lot of times you're going to find that there are either 2, 3, or 4 forces acting on an object. Not always. There can be 5 or 6. Most of these, though, there's going to be 2, 3, or 4. Okay, so something to keep in mind. I'm going to pause this now, because like I said, we're not doing this one, because it got confusing. And we're going to move on to a different page. So I would suggest you pause this, write this down if you haven't been while we were going, and I am going to move on to another thing. So going once, going twice. All right. Oh, I need to maximize this. Okay, so this is page 1 from your packet. I'm not doing all of these. I am going to have you do a couple of these, and then I'm going to go through and give you what the correct answers are to help you check and make sure you're doing them right. Okay, so first one up here, we have a helium balloon floating away. So pause this, do a free body diagram for this one, and then come back and we'll check and see if you did it right. All right, I'm going to move on, assuming that you've paused that. All right, so looking through our list, I erased them over here, but the first one we always said is gravity. Is there gravity acting on the balloon? Yes. It's going to be relatively small, but you can measure the effect that gravity is having on this balloon. So there is a downward... Hey, I didn't turn on... Hang on. Need to turn the pen on. There is going to be a downward What the? Okay, one sec. Okay, I think I fixed my pen. There's going to be a downward force of gravity acting on the balloon, because gravity is always down. Okay, then we have our three flight forces: thrust, drag, and lift. Thrust, no, there's no engine. Drag, I'm going to come back to. Lift, definitely no, there's no airfoil on this. Drag is arguable. In this case, in a problem like this, you could argue that there's probably drag, but the question, the prompt, doesn't say anything about wind. So in this case, I'm going to say that the drag is probably something not worth mentioning. If we knew a specific direction the balloon was going in, then yes, drag would be on there. This would be a case where if you put drag, you would not lose points. But I'm not going to be looking for it because it's very unclear on this whether drag is present or not. Then we have our other five forces. Friction, no, because it's not in contact with anything. Normal, again, not in contact with anything. Buoyancy, yeah, it's floating. Okay, there is a buoyancy force being exerted on this balloon. And it's having a measurable effect because the balloon is floating away. So there is definitely a buoyancy force, and buoyancy is always up. Okay, then our last two, applied and tension. Since the balloon is floating away, there's nobody holding onto the string, there's no tension. This would be the case where the light string doesn't count as a tension force unless it's tight. And applied force, nobody's pulling on it, so that's it, just these two. Again, if you have drag, that's fine. You're not going to lose points if you put drag on something like this because it's not really clear whether drag is there or not. Okay, that brings us to the chair, and the first tip that I'm going to give you is I forgot to draw a floor on this. I don't know if that matters to you, but it's been bugging me, so that is the next one I want you to work on is the chair. So pause this, do that. All right, I'm going to assume you have. So first one, weight. Is FG acting on the chair? Yes, it's sitting on the ground, so they're pulling it down. Okay, then we have our three flight forces, lift, drag, and thrust. So thrust first, it's a chair. There is no engine on it, so no thrust. Lift, there's no airfoil, so there can't be any lift. It's also not moving, which means there can't be any drag. So none of our flight forces in this. You're going to start to notice that the flight forces tend to come in sets. They're either all present or they're not present at all. Except drag. Drag's the one you have to keep an eye on. Lift and thrust should be obvious when they are there. Drag sometimes can sneak up on you. Keep that in mind. So that's it for our first four. That brings us to our five other contact, which are friction and normal, first off. Doesn't say anything about the chair moving. It's not on a slope or on a hill or anything, so we have no reason to think the chair is trying to move. Normal, yes. It's in contact with the surface, so there has to be a normal force. In this case, perpendicular surface of contact would be straight up, because again, doesn't say anything about a hill. So we'll have an Fn up. Again, not moving, no friction. Buoyancy force. Arguably, yes, but not a measurable effect, so we're going to ignore it. And that leaves us with tension and applied force. With no person pushing on the chair or sitting in the chair, we are going to say that there's no applied force here and no tension. So again, just two forces. And the last one I'm going to do is this one. Okay? So, table with science teacher standing on it. That sounds weird. Who would ever do that? So, draw this one out. Well, don't draw it. You've already got it drawn. But draw what you think would be the forces acting on the table. Okay? The table is the thing we're actually looking at forces on. Okay? So, all right. FG. Gravity is pulling down on the table. So, there is definitely a downward FG. Now, you might have put the weight of the person here as a second FG. That's fine. We'll come back to that in a second. in a second. We'll come back to that at the end. Flight forces, nothing's moving. There's no flight forces on this. There's no engine. There's no airfoil. No flight forces. Friction. There's no indication that the science teacher is moving around at all or trying to move the table. So we wouldn't say friction, but there is definitely a normal force because the table is sitting on the floor. It looks like it's hovering in the picture, but it would clearly actually be sitting on the floor. So we have a normal force up on the table. Buoyancy, arguably, but no. Then we have applied force and tension. There is no tension because there is no strain. Applied force, though, is arguable. So this is another case where, this is one of the cases where there's technically an applied force, but it doesn't always look like an applied force. So the teacher standing on the table is exerting a force on the table. It's his weight. Earth is pulling down on the teacher, so the teacher is then pushing down on the table. So there are two ways you can note this. You can put a second FG, which is fine. You need to note which one's which, so you need to say psi and table, so that we can tell that you didn't just put the same force twice. But the more accurate way to put this would be to call it an applied force, because the science teacher is applying a force. He's pushing on the table. Okay, and that's it for this video. That's all of these that I'm going to walk you through. You have, I guess there's 9 on each page, so you have 27 of these to work through and practice. And that's pretty much it. I'll just talk about this. If you look on your actual worksheet, I underlined things. I probably should have mentioned this earlier. This first page doesn't have anything bolded like the other pages do. So I went through and I manually underlined things. Whatever is bolded or underlined, that's the thing that you're acting on. That's what you're trying to judge the forces. That's why it's the table here. Okay, I underlined table in your description. That is it for this video. So have a wonderful whatever, and I will see you next time.